everybody. Good morning, good afternoon, good evening, depending on whatever time you are listening to this recorded session. So the plan for this session is I will be going through the ERD practice questions. So I'm hoping before you listen to this lecture, you have gone through the basics of ERD. You understand what one-to-one, one-to-many, many-to-many relationships are. You have revised the lecture, the first lecture or on the ER diagrams, and now you're ready to practice some questions. So, that's me. Hope everybody is doing well. I'm ready with my big cup of coffee, and I'll suggest you do the same. Okay, guys, so let's get started. Okay, so before we start with some of the questions, there are two tools you can use to draw ER diagrams. Of course, you can do it on a piece of paper with a pencil or pen as well. But if you want to use some tool, I will recommend either using Lucid Chart or Microsoft Visio. Microsoft Visio is generally what most of the companies uses, but it's a paid software, so you have to buy it. Lucid Chart is very similar to Microsoft Visio, and the good news is it's free, at least the basic version of it. I think the school labs, we do have Microsoft Visio 2013, I think the version installed, so you can use it there. Lucid Chart, if you click on this link, let's see, let me log out. I'm already logged in. So when you click on that, that's where you will land, and you'll say sign up free if you want to use this tool. And there's, as you can see, there's no option here for free, basic, pro, team, but right here is your free basic account. So click on that, your name, username, or your email ID and password, and you're all set. Or you can sign up with your Google account as well, okay, which I've already done. So I've done it with my I think you get a free account for longer time or with more options if you use the .edu email ID. I don't remember exactly, since I did this maybe more than a year back, so I don't know whether they still give you some extra features or the free version, something associated with .edu, whether it still exists or not. I don't know exactly what's happening right now, but as my account exists for nearly 2 years now. Okay, so you log in, you can create documents, folders, or you can import it. You can even import Visio files. So I'm going to you can say plus, and it opens a blank document for you, and that's the canvas you have. You can zoom it, zoom out. So zoom in, and right here you can see there are many shapes. Flowchart, we don't want these shapes, so I'm going to click here, right on the shapes right there, and I'll unclick those. All I want is the entity relationship, but there are other options for UML, which is, some of them are really good for you can do your use case diagram for system analysis and design related material. UI mockup, if you are designing a user interface mockup, Android phone mockups, iOS, Apple phone web design mockups, data flow, cloud platform, Venn diagrams. A lot of options available. So right now we just need entity relationship, and I need the default one. So I'm down to those two. There are various kinds of options available for the entity, or 4 to be precise. 1, 2, 3, 4. So these are the 4 kinds of entities you can have. What's the difference between these two? 3 column, 2 column, 2 column, different 2 columns, 1 column. They're all, you can use either one of them. It's just that when you use 3 column or 2 column, we are giving more information. We are entering more information in a document, which is really good. That means more information is shared with others and then passed on to the database administrator as well. I would suggest using this 3 column one. So student, and field is student ID, and in this case it's primary key, and type would be text 10. What is this type or this text 10? We will discuss that in one of the later lectures when I will discuss data type. Name, or sorry, first name, date of birth, which is date, and name is also text, let's say 25 size. That's that. The only difference, the difference between other entities would be in this: we will have only the name here, the field name, I mean student ID, that's all. There's no other separate columns to enter the data. So student ID, and if you want, you will say PK like that, and maybe text 10 in there. So a little bit more, you know, difficult to enter information. Here you have entity name, field, student, and it has a separate column to enter primary key, but again you will enter text here. In this option you will enter student, field would be student ID again, and this should have been an ID2, and here you will say text 10, and no separate column to specify whether it's primary key or not. So again, there is no fixed rule about which one to use, but this one is, in terms of, you can say, drawing or representing your data, a little bit more cleaner, more data we can enter and recommend it. Okay. And the one key thing is no empty spaces in either attribute name or the entity name, just to make it a little bit more better. Or you can do alternate or something like this. So all these options are available. You want to add more fields, more attributes, sorry, like that, you can keep on entering. You can do all that, and increase the size, you can do that as well. So all those options are available. So that's how you design an entity in Lucidchart. How do we connect them? That we will do when we start doing the example. I'll show you at that time. So I'm going to go back, and I was already working on something before. Let me open that one. Okay guys, so continuing, going back to this thing. Okay, so let's do now some practice questions. The first question is, create an entity to describe the products in a sandwich shop, and those products could be sandwiches, pastries, drinks. So make an entity to store data on all these various products which are available in a sandwich shop, and you can say there might be something else like soup, pasta, pastry, or pastry is already there, pizza, burgers, whatever you can, whatever kind of product you wanna think of. So what I would recommend is when you're listening to this lecture, whenever say draw a diagram, pause my video, think about the answer, what you will do, draw it on lucid chart or on a piece of paper. So before you continue watching the video or look at the solution or hear me, pause for a couple of minutes, pause the video right now and think about your answer. Even if, let's say, just think about it in your mind. So go ahead, pause it. Now you have unpaused it, so let's look at the answer. Most of the times I've seen in my experience that since this is the first attempt to draw an ER diagram, first question, a lot of students at this stage end up drawing 3 different entities. So they end up drawing 3 different entities, one for beverages, one for pastries, and one for one for sandwiches. So they end up drawing 3 different entities, which is incorrect. And what would be the right answer? So we will say product. The first thing is, of course, the primary key. So product ID, which is the primary key. Its name and price. Okay. Text size 10. This is also the product name, text, maybe 20. Price, number. Okay. So now the question would be, how will we differentiate whether it's a pastry, sandwich, or a beverage? And so we can simply have an entity called type, which attribute, which can tell us what kind of product it is in the description. So you can write sandwiches there, pastries, or whatever. So that will tell us what a certain product is. But again, the key thing to remember here is that only one entity to represent all kinds of product which we have in our pastry shop. First question. So that's our answer. Which attributes of the product entity should be required? So is product ID needed for all kinds of product? Absolutely. Product ID cannot be empty or not null. If it's required, we make it bold. Is name required? I think so. Price, yes. Type, absolutely. So it looks like here we need every kind of all the attributes are needed. But let's say there was certain attribute like which was only relevant to only one of this, like maybe which was only relevant to drinks, not sandwiches or pastries. So if there was such field, I'm just going to call it only relevant only relevant. Come on. Only relevant. Come on. To one kind of product. I'm just this is not an attribute really, only relevant. I'm just trying to show you what I mean by that. So some attribute only relevant to one kind of product. Let's make it optional. Why? That's when you are entering the data for sandwiches, there's no particular thing for this data. So leave it on unbold, just like we did for home phone and cell phone kind of thing. Okay. Which attribute would make a good primary key? We have already done so. Product ID is the best thing, just like customer ID, student ID, course ID. Product ID would be the primary key, and we type in PK next to it to donate that to tell the other users as well as system administrator. Moving to the next question. Here are two entities, recipe and ingredient. What kind of relationship exists between these entities? So let's draw it out. Just to keep it a little easier in the demo, I'm just going with this single column entity. So first one is, come on, what's the name of the first one? Let me look at my book where I have the same thing. Recipe, and the other one is ingredient, and this is recipe ID, which is a primary key here, and here is eng. Okay. So now we have to define the relationship among them as the question asked us to do. So go ahead, pause the video, think about it, and then unpause it. How do we draw a relationship in ER diagram? You bring your mouse here. When the red dot starts, start putting it here. So we just connected them. So this is right hand side one symbols, left hand side window symbols. So that's how we can change it. Okay, so let's think about this. One second, let me put that also here. So remember, we have to decide max and min relationship between two kinds. So recipe at the maximum can have many ingredients in that. Yes, so it's many, and at the minimum it needs at least one ingredient. So that's your answer. Ingredient at the maximum can be in, I would say, more than one recipe. Like salt can be more than one, and an ingredient at the minimum, what if we have an ingredient which we have not used at all in any of the recipe? Of course, there are recipes in which that ingredient would be used, but we don't have it in our record, in our database. We do not cook such recipes. So I would say optional at the minimum. So that's the relationship between these two entities. Okay, so now the fifth question is, how will we resolve this relationship? What do I mean by that? Many to many relationship cannot be implemented in a database, right? So we have to resolve this. We have to break this relationship by introducing a third entity called an associative entity. What's the name of that? Let's name it, you can give it any name you want. So first three letters from that, ingredient and recipe. So bring this here and bring one more from here. Associative entity, many symbol is here, many is here. This would become one optional. Okay. And same thing here. Oops. So we brought the many symbol on the child one of both of them, and when this one has the many symbol, this is a child, then we have to bring the primary key from the parent as well, which is called foreign key here, but it will also become the primary key. And then we have ingredient, and which is foreign key, and combined together with recipe it becomes primary key. So for the rec ing entity, we have both recipe and ingredient key. Recipe, oh sorry, this should be recipe ID and ing. Okay. So that both of them feel together are composite primary key, and you can also call it one prime foreign key and second foreign key. So that's how we will resolve the many-to-many relationship between recipe and ingredient by introducing a third associative entity, sort of child of both, and the many symbol comes on the associate. The first parent's primary key come here as a foreign key, the second parent's primary key come as a foreign key, and then those combined together become a composite primary key. So they're both together primary key. So that's how we will resolve this relationship, by doing that. Moving to the next question. An instructor has decided that he needs a relational database to store grades, and the instructor, that's been gender neutral, the instructor has defined following three entities: student, course, and assignment. What should be the relationship among them? Again, I will recommend pause your video and think about the answer. Okay, so let's define the relationship between these three entities. And how should we do that? Right here, right here. Again, let me bring that here. So a student at the maximum can take how many courses? Many. And at the minimum, maybe none. You know, certain semester student is not taking any course. A course can be taken by how many students? Obviously more than one. Very difficult to teach everybody individually. And at the minimum, I would say none, because certain semester a course might not be offered. A course at the maximum can have how many assignments? Of course, more than one. Like in this course, you have multiple assignments. And at the minimum, I would say most likely you will say the minimum a course should have one assignment. But what if there's certain course like capstone course or something like that course where you don't have any assignments but just an exam? Sounds like a fun class, no assignments. But there are certain courses where you have or call by conference where you just do one big project, and sometimes in an honors program, one big project at the end of the course, no assignment. So to make sure we cover all the scenarios, I will make it optional. Generally, assignment belongs to one course. Assignment is related to a particular course, and at the minimum, a assignment can be not be part of any course. That's it was part of a course sometime, but now we don't use it. It's been discarded or got old. Course has changed, the curriculum has changed, or just like the new book year edition comes out, you introduce new assignments. And now we have one more relationship left, that's between student and assignment, because assignment is done by student, you get score on it. So a student at the maximum will get how many assignments? Hoping more than one, many. And at the minimum, I will say optional, just like because you might not be taking a course, or you might be doing only a capstone course in the end. And an assignment can be given to, at the maximum, how many students? More than one or student. And minimum, again, optional. Assignment might not be assigned to anybody. Okay, so that's what our answer is. So if you look at this, we have many-to-many relationship between these two entities and many-to-many between these two, which would imply that we have to introduce one associative entity here and one here to take care of that many-to-many relationship, resulting in something like this. So this is the one associative entity, and the other one right here. So that's the answer to that question 7. Moving to question number 8. A dentist office has 3 dentists, 2 hygienists, 5 dental assistant, 2 administrative assistant to maintain the office. They're creating a database to track appointments and also to track who works with each patient. So let's draw an ER diagram, entity relationship diagram for this. First entity for this. Again, think about your answer. Pause the video for a minute. Pause. Okay. So I hope after doing question number 1, you have learned something from the first question we did about the product, and you are not saying that we should have an entity called dentist, hygienist, dental assistant, administrative assistant, because they all are working for this office. They all are employees. So we can put all of them under the employee entity, because they all are different kinds of employee, and we can put an attribute called type to know whether they are dentist, hygienist, assistant, or administrative assistant. The other entity which we will need is something to track appointment. Let's call it appointment, and something to track patient, which we could call patient or customer. Either it would be fine. So let's draw that. And again, I'm just using the simplest entity for this example. I will recommend use this one for your work. So employee, come on, this thing is a hassle. employ with emp id, which is the primary key, text 15 maybe. Second one is patient or customer, whatever you want to call it, patient id primary key, and appointments with appointment id as the primary key. Okay, so let's define the relationship first between employee and patients. Employee can see many many patients, and if you look at, let me get that more too. There's a little bit more to the question which I want to show to you. So when you create an entity relationship diagram, remember several employees, dentist, assistant, hygienist, can be involved in a single appointment for a customer. You know, in a single appointment there might be a dentist, dental assistant, and then you might have interacted with the administrative assistant as well. So what that means is an employee, of course, will have many patients, at the minimum maybe none, and a patient will be meeting with many employees. Okay. Now a patient has appointment. You know, you might be taking a customer can be taking many appointments. Or might not have taken any appointment. Appointment is given to one patient 9:15, or appointment is given to one customer, or maybe nobody might have any appointment at a certain time. You know, let's say nobody's coming to our office at 9:15. So what it says here is that a employee and patient has many to many relationship, which will need a third entity. And this is a little bit a tricky thing here. So we will introduce a third entity here. Or, you know, let me break that. Since appointment is a child of patient, so we will add something called patient ID here as foreign key. So now this question is a little bit tricky, as we saw earlier that employee and patient had many to many relationship. So as such speaking, this would be, you know, their interaction details or appointment details. This should be connected to this one. But there's a little bit different we are doing here, because if you read back the question, we are trying to track appointment with each patient. So when you are tracking each individual patient, okay, actually I think I made a mistake. That's what happened when, you know, you think you are yourself an expert and you don't read the question that clearly. When I was reading the question again and from the book as well, I realized that a patient take can get many appointment, and for that appointment, that record that appointment. So let's say you have an appointment of 11 o'clock today. That appointment might is associated with a dentist, with a hygienist or whatever. And then the name patient might take another appointment for a week later. So, because a patient can have many appointments, and that appointment might be associated with some other employee or dentist. So patient and employee will not have any direct relationship, as what I have put earlier. No, that was my mistake. So what it should be is that an employee should have relationship with a appointment, which includes the appointment time, day and time, and the patient ID as foreign key. So we have patient too, and that was a many to many relationship, because the employee can be involved in multiple appointments, of course, and for an appointment we can have many employees, because that's what our questions said. Several employees can be involved in a single appointment. So this relationship is many to many, and we will need to introduce an associative entity in between these which would mean our final entity relationship diagram will look like something like this. And of course they have named it customer, I have named it as patient. So again, the reasoning: employee is not directly or dentist is not directly connected with patient is because a patient takes an appointment to meet with the dentist and employer, and so the relationship between patient and employee is via appointment. Because again, why is that? Why did we put appointment there? Why is the relationship via appointment? Because a patient can have multiple appointments, one appointment every month. So that's why one too many. And for that appointment, which might be every month, that appointment has an associated dentist or employee with it. So there's no direct interaction between the employee and patient. That interaction is through their appointment, that scheduled time when the patient is coming to the office. So that was the first my questions for the ER diagram, for the entity relationship diagrams.